Hi, my name is Chris Kellett and I'm a professor of electrical engineering at the University of Newcastle. Our starting point for the first series of videos is the greenhouse effect and the physical mechanism behind it. First, all objects, such as planets and stars, emit electromagnetic radiation at various wavelengths. The radiation wavelengths are related to the temperature of the object. For example, the Sun emits a very wide spectrum of wavelengths, while the Earth emits a narrower spectrum. Three things can happen when radiation hits an object. It can be transmitted or pass through the object, be reflected, or be absorbed. Think of a window in full sunlight. From the outside, you may see some glare on the window. This is reflected radiation. From the inside, a room may be lit up. This is transmitted radiation. Finally, the window itself may become warm. This is absorbed radiation. The different gases that make up our atmosphere have specific properties that mean they have different effects on radiation of different wavelengths. That is, at one wavelength, a particular gas may transmit electromagnetic radiation, while at another wavelength, this gas may absorb electromagnetic radiation. Look at these graphs. These graphs show the rate, or percent, of absorption of particular wavelengths for a few greenhouse gases on the bottom, with more black on a vertical line indicating more absorption at that wavelength. The visible wavelengths are indicated by the rainbow. Ultraviolet light, at small wavelengths to the left, is largely absorbed by the greenhouse gas ozone. Light in the visible spectrum is largely unimpeded. However, the Earth emits radiation in the near-infrared and infrared spectrums, and here we see a significant impact from carbon dioxide, or CO2, with two peaks in absorption in this range. This is the main physical process that drives global warming. Solar radiation covers a wide spectrum, and much of that radiation passes through the Earth's atmosphere to impact the surface, raising temperatures. The Earth emits electromagnetic radiation back towards space, but greenhouse gases absorb radiation at precisely some of these wavelengths, heating up and emitting that heat back in the direction of the Earth's surface. It is important to note that this process makes the Earth habitable. Indeed, as the surface of the early Earth cooled some 4.1 billion years ago so that water could exist as a liquid on the surface, the Earth's atmosphere consisted of high concentrations of greenhouse gases. This allowed the Earth's surface to remain above the freezing point for water. In fact, it is estimated that with no greenhouse gas in the atmosphere, the Earth's surface would be about -18 degrees Celsius. Clearly then, the greenhouse effect was present long before the Industrial Revolution of the 1700s. Greenhouse gases include carbon dioxide and water vapor, and the major source of these gases in the early atmosphere were due to volcanic activity. Subsequently, and particularly during the last 100,000 or so years, while atmospheric greenhouse gas concentrations have varied, they have done so in a fairly narrow range. This in turn provided a relatively stable climate during which humans evolved and civilizations flourished. However, with the advent of the Industrial Revolution in the late 1700s, humans began the large-scale burning of fossil fuels, which, as a byproduct, has significantly raised the concentration of greenhouse gases in the atmosphere. This means that now, when the Earth emits electromagnetic radiation towards space, more of that radiation is being absorbed by greenhouse gases and then re-emitted back towards the surface. In turn, this leads to a gradual warming of the Earth's surface. In the next video, we will discuss specific greenhouse gases, their classification, and their impact.